Hello students, today's class is about how do acids react with metals. What happens when acid reacts with any metal? So before going to that, let's start with an experiment given in activity 2.3 of textbook. In this activity we are going to react an acid. This is sulfuric acid. I have taken this acid in a test tube and I will be adding zinc granules. Zinc is a metal, so I will be adding pieces of zinc into dilute sulfuric acid. Let's see what happens if these pieces are added to acid. Now the reaction has started. You are seeing bubbles coming out of the acid or the surface of metal. Actually it is coming from the surface of metal and the reaction is taking place. Let's wait for some more time. Just heard a sound of one more reaction. This is the same reaction and the popping sound you just heard is obtained when the gas coming out of this solution, this acid, is reacting, is burnt and is reacting with oxygen. So in another way we can say that the gas is being combusted, ignited, and now let's see once again what happens. The reaction has gained speed and it is you can see bubbles are forming on the surface also. It is going that fast and I am going to bring a burning candle close to it so that we can see the reaction though. I am closing the mouth of the test tube so that you can see. It will take time. The bubbles are coming very rapidly. The reaction is going fast and this is a kind of reaction in which displacement is taking place. You have learned about displacement reaction in chapter 1. This is what happening, and a reactive metal, here it is zinc, is displacing something. We will know what is going to happen. This is popping sound. This comes when the gas coming out of the mixture or the solution is burning, and when it burns it reacts with oxygen. So this is happening. Let's turn this reaction which is taking place in this test tube into a chemical equation. Let's see the chemical equation in which we are using zinc granules. I am writing S for solid because these are solid granules. They are reacting with dilute sulfuric acid, H2SO4, and that is dilute means it is aqueous. Is understood? And then displacement is based on reactivity. Very more reactive element or metal displaces less reactive element or metal from its compound. In this case, when acids are being reacted with solids, with metals, the reactive metal will always displace less reactive element from the acid. Let's see what that element would be. Now in this reaction, zinc is displacing less reactive hydrogen to form zinc sulfate, ZnSO4. In aqueous plus gas, hydrogen gas is liberated. Hydrogen gas is highly combustible. It has very low ignition temperature. It burns with the popping sound. So we just heard and seen the reaction taking place. I'm going to try it once again. Now the reaction has very increased very rapidly to higher extent once again. So it depends for how long I can stop these bubbles inside the test tube. The gas is being liberated and it has to be burnt. If I'm, I'm again doing that, pops out. So you have to be careful while dealing with such type of reactions. Okay, let's proceed. Now, how do we know that hydrogen is going to displace, is to be displaced by zinc or any other metal, or whether it will be displaced or not? It depends on the reactivity. So for this, you have to turn to page number 45 of your textbook. In that chapter, the reactivity of certain elements is compared. They have compared the reactivity of certain elements or metals with hydrogen. So let's note it down once again and see what is going to happen if acids react with metals. You can clearly find out from that concept. Starting from potassium, it is highly reactive, then its neighbor is sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, and then silver, gold. This is the reactivity series given on that page. You have to memorize that reactivity series as soon as possible because it is going to be used again and again, because in this chapter also these elements are they are reactive. The elements above hydrogen are reactive, they are very highly reactive, and these are less reactive, and this is the least reactive. Now, in an acid, we know the definition of acid. We have learned that acid is a substance which gives H positive ions in its aqueous solution, and H positive ions means hydrogen. So any element, any metal reacting with an acid can displace hydrogen only if its reactivity is more than hydrogen. So these are the elements or metals which are going to displace. Displacement reaction, double displacement reaction, that in that case this is also helpful. In this chapter this is going to be helpful once again, and in third chapter it will be used again. That is why it is given on that page, but still it is it will be better for you to memorize or keep it in your brain that these elements are highly reactive and these are least reactive or less reactive, and the elements above hydrogen can displace hydrogen from its acid. So let's take few examples. Let's start with potassium, highly reactive. We are using potassium. Let's its physical state be solid. Reacting with, let's take dilute hydrochloric acid, HCl. Okay, and in that case it will be aqueous. Reacting with this reaction, going with this reaction, we come to know that potassium is positioned above hydrogen. So in that case, it will displace hydrogen. So in hydrochloric acid, the new product formed is KCl. KCl for potassium chloride. And this is in aqueous medium, and hydrogen will be given out in the form of gas. Now this is not a balanced chemical equation. So we have to balance it. I'm keeping this arrangement with me right now because we are going to see more reactions, and this will be helpful to understand the occurrence of those reactions, whether those reactions will be possible or not. I mean feasible or not feasible. So this is going to happen because potassium is above hydrogen. It is more reactive, so it will displace hydrogen. This is going to happen. Now let's see another example when magnesium is reacting. Let's take magnesium solid and it is again reacting with hydrochloric acid in aqueous medium and it will form its salt MgCl2 that will be water and again hydrogen gas will be given out. Again we have not balanced this equation. You can easily balance it. As you know, there are 2 chlorine and 2 hydrogen and 1 magnesium. To the left we don't have 2 hydrogen, 2 chlorine, so we can make it 2 by putting 2. Sorry, can you put over here? It will be much better. So this is the chemical equation, balanced chemical equation in this case. And let's take another example of reaction of aluminium. Aluminium solid plus dilute. Again, let's take hydrochloric acid in aqueous medium, and then formation of aluminium chloride takes place in aqueous medium and liberation of hydrogen gas. Now the question is how I am forming these compounds. You already been taught about this in class 9th. Recall that when magnesium atomic number 12, electronic configuration 282, and it has 2 positive charge, whereas chloride ion has -1 charge. So you wrote these values like this and interchange these value during that time, and you got MgCl2 in class 9th, and this is going to happen. That again in this class you have to recall those reactions or combinations or concepts once again. So this is magnesium chloride, and now how about aluminium chloride? Aluminium is Al3 positive, that means you are going to take 3, and if it is chloride ion it will be taken 1, and after interchanging those values it will be 1, no need to write 1, and in case of chlorine it will be Cl3, so AlCl3 is forming, aluminium chloride, magnesium chloride. Now let's balance this equation. You already know how to balance equation, so let's recall once again. We have 3 chlorine atoms and to the left we don't have any, only 1 chlorine atom, so we have to balance it. Moreover, we have 2 hydrogen. Now, if it is written 2, then how we are going to balance chlorine? In case we are writing 3, how we are going to balance hydrogen? So it's better to take common numbers, multiply them 3, 2, and take it 6. 6 HCl. So in that case, you have to make it 6 by putting 3 and 6 by putting 2. Now 6 chlorine and 6 hydrogen and then 2 aluminium. You can put 2 over here. So this equation is balanced chemical equation for the reaction. Now let's react other acid. Take example, if we are reacting potassium, again take potassium solid plus reacting with let's take dilute H2SO4 sulfuric acid and proceed further. Now will this reaction occur? Yes, it is going to occur because potassium is more reactive than hydrogen. It has to happen. So displacement reaction will take place. Potassium will displace hydrogen and it will form potassium sulfate. This is potassium sulfate, and then again the gas coming out will be hydrogen gas. Is this balanced? Yes, it is, but you have to put 2K because we have 2 potassium at the right hand side. Let's take the case of magnesium. Again, magnesium metal reacting with dilute H2SO4. Reaction will occur, it has to occur because magnesium is above hydrogen. It is more reactive than hydrogen, so it will displace hydrogen from its acid. So the product formed will be MgSO4, magnesium sulfate, aqueous solution, and then how many hydrogen? 2 hydrogen. Hydrogen gas is given out. And is this chemical equation balanced? Yes, it is. It is balanced. We have sulfate ion, complete sulfate ion 1, and we have 1 sulfate, 1 magnesium, 2 hydrogen, 2 hydrogen. So this is balanced equation. Now let's take one more example. Whether this is going to happen or not. Let's mercury. Mercury liquid at room temperature. It's its property reacting with hydrochloric acid. Let's take this acid aqueous solution. Now, is this reaction going to happen? Is it feasible? No, it's not feasible. It's not feasible because this metal, mercury, is below hydrogen. Hydrogen is more reactive than mercury. Therefore, this reaction is not going to take place. Now, this is what happens when acids react with metals. In some cases, some reactions proceed to some extent and then stop because there is formation of oxide layer on those metals like aluminium. Aluminium has a tendency or property of forming oxide layer on its surface, which prevents further oxidation, so reaction is not going to proceed further. So we have to take that into consideration. Okay, this is what you have to keep in your mind, that more reactive elements will displace hydrogen from its acid, whatever the case may be. The reaction will take place according to this reactivity series.